Hello and welcome once again to the Aakash Byju's JEE channel. My name is Atiullah and I'm back with another live session on JEE Mission 2022. So before we get started with this session, just let me know if you can see me properly and you can hear me properly. Alright, give me a thumbs up, give me a yes so that we can get started with this session. Just let me know if you can see me properly and hear me just fine. Alright, so that we can quickly get started with this session. Alright, cool. So I can see some thumbs ups, I can see some yeses. Alright, perfect. Alright guys, how are you? How are you doing? A very happy new year. I hope you got the time to relax. I hope you got the time to re-energize. And with this new energy in the new year, let's get this session started. Okay, so we are here with JEE Mission 2022. We are already in 2022, so now it's really close, and so we should push the tempo a little bit higher, right? So in this session we're going to deal with current electricity. Current electricity is another very important chapter. It is a high ROI chapter. You get high return on investment. And why do I say that? Because current electricity, it has one part with a lot of different concepts, but there is one big chunk of this chapter which deals with circuits. And if you understand the circuits for current electricity, you're automatically going to understand the circuit for capacitors. So effort is just for once, but you're going to get advantage twice. Alright, so let's get started with this session on current electricity. We're going to discuss important concepts and we are going to solve some important conceptual questions. Alright, so my motive is to revise the important concepts and take the fear away from you. Alright, so if you're ready, let's get started. So you know the format. I'm going to throw questions at you. Then you are going to tell me what is the concept that we are going to use to solve the question. We are going to discuss the concept, and once that is clear, we're going to solve the question and move ahead. Alright, let's get started. So here is the first question. Okay, so we have a conductor of length L and it has a circular cross section as shown. The radius of cross section varies from A to B. The resistivity of the material is rho. Assuming that B minus A is much less than L, find the resistance of the conductor. Okay, so in this question we need to find out what is the resistance of the conductor. Now it is very simple to understand that the resistance of the conductor is given by rho L upon A, right? We know that very well. Rho is the resistivity, L is the length, and A is the area of cross section. We know this very well. But what is the tricky part here? The tricky part here is that the area is not constant. Can you see that? The area is not constant. Here the area has a radius of cross section of A. Here the area has a radius of cross section B, which means that we cannot directly apply this formula over here. Okay, so I hope the question is clear. So my question to you is, how do we go about solving this question? Okay, can you let me know how should we proceed with this question? What is the concept we should apply and how do we go about this problem? Quickly let me know. What do you think? How do we proceed? Alright, Captain Jack Sparrow, good to see you again. And Captain Jack Sparrow is right again. We will have to use integration, right? Because we cannot directly use this formula. So you can understand that we'll have to break this entire resistor into small resistors, okay? And how do we do that? What we're going to do is we're going to take a representative element. And how do we take the representative element? At a distance x from here, okay? At a distance x from here, we are going to take a thin circular disc. Yeah, what are you going to take? We are going to take this thin circular disc which has a thickness of dx. Is that right? Okay, and this radius for this disk, we are going to assume it to be r. Okay, so the radius is changing from A to B about, so the radius is going from A to B, and over what length it is going from A to B? It is going from A to B in the length L. Okay, over the length L, the radius is changing from A to B. Is that right? Okay, so if I take R as the radius, then what will be the resistance of this small part? Okay, so this resistance of this small area we have taken is going to be how much? It is going to be rho L by A. Is that right? It is going to be rho L by A. But what is the length here? What is my resistance that I'm talking about right now? It is a thin circular disc, and this thin circular disc has a length of how much? The length is dx. Is that right? So I'm going to write dx in place of the length, and I'm going to divide it by the area. Okay, what is going to be the area? The radius of this disc is r, so what will be the area? The area is going to be pi r square. Is that right? So what are the things that we don't know? We don't know what is the radius. So our job is to convert this radius in terms of x. Is that right? Then only we can integrate it. We already have a dx, so we'll have to convert this radius in terms of x so that we can substitute it there and go ahead with integration. Now can you tell me, how do we do that? Do you have any ideas how can we convert this x in terms of r? Can you let me know? Do you have any thoughts? How do you think we should convert x in terms of r? That is the critical part of this question. Otherwise, it's just simple integration. Is that right? Do you have any ideas how to do that? We can do it in multiple ways, right? But I want to know from you, what is your understanding? Okay, so what we're going to do here is, so we should understand that the radius is going from A to B uniformly. Okay, it is going increasing at a uniform rate. So if I draw a line over here, then the radius is going from A to B and the slope is uniform, it's constant. Can you see that? Okay, this angle over here is a constant. So what can we say? That the radius is increasing at a uniform rate. Okay, so for unit change in length, the change in the radius is going to be constant. Do you get that concept? For unit change in length, the change in the radius is going to be constant. Is that right? So we can use that concept to find r in terms of x. So listen to this very carefully. What are we going to do? So what I'm going to write over here is, I'm going to write the change in the radius over length L. Okay, so what is the radius changing by? So it is changing by b minus a. Can you see that? The radius was a, now the radius is b over here. So the radius has changed by b minus a. And over what length it has changed? It has changed over length L. Okay, so per unit length, the change in the radius is b minus a. Okay, now where are we? We are over here. And what is this length? This length is x. For this length x, by what amount is the radius going to change? It is going to change by b minus a divided by L into x. And can I say that is going to be the change in the radius? Do you understand this? Okay, so for unit change in length, the radius has changed by this amount, b minus a upon L, simple unitary method. So for length x, the radius is going to change by b minus a divided by L multiplied by x. Is that right? So if we are going from this point to this point, then the radius is changing by this amount. What does it mean? It means that now the radius is going to become, what was the radius over here? The radius over here was a. And what is the change in the radius? The change in the radius is b minus a upon L multiplied by x. Okay, so this is how we are going to find out r in terms of x. There is another way you could have done it. So what you could have done it is, you could have produced it backwards, and then you would have taken this angle theta, and then you would have written three equations. Let's say this is z. Okay, so you could have said that tan theta is going to be equal to a by z. Can you see that in this triangle? tan theta is going to be equal to A by Z, and then tan theta is also going to be equal to how much? It is going to be equal to R upon Z plus X, and this is also going to be equal to B divided by L plus Z. Okay, we could have done this, but we'll have to solve two simultaneous equations, eliminate two things, and then find out the relationship. A better way to find out the relationship is this. Okay, this is the general method to do it, but a better way to do it is this. Is that clear? So what have we found out? We have found out what is the radius when we have reached this point X. Is that correct? Now all we have to do is substitute it here and then integrate. Okay, perfect. Let's do that. Okay, so what I'm going to do here is I'm going to write dr is equal to, we have dx over here, we have rho over here, and then we have to write pi r square. Now what is r? R is a plus b minus a divided by L into x and the square of that. Is that correct? Is that clear? So all I have done is I've substituted for r. Okay, so now we can integrate this. So if we integrate dr, then what are we going to get? We are going to get the total resistance. This dr is the resistance of this representative element. If we integrate that over the correct limits, we are going to get the total resistance. Is that right? So what will be the limit of integration? So this is going to go from 0 to r. And here, what is my variable? My variable is x. So my x is varying from this point, which is x equal to 0, to this point, which is x equal to L. So this integration is going to go from 0 to L. Is that right? Okay, so Narendra is asking me, sir, can you explain how we got to RHS again? Okay, no problem. So Narendra, is this clear? How we found out what is the radius? Okay, is that clear? So that is what is the critical part. We have found out the radius. Okay, now we are talking about RHS. So dr, so what is the resistance? The resistance for any resistor is rho L by A. Okay, now what we have chosen as the resistor over here is this representative element. Okay, what have we chosen? We have chosen this thin circular disc. Is that correct? Okay, this thin circular disc. So this is going to be rho. So let me substitute rho over here. Correct. Now we have to substitute the length. Now what is my resistor? Forget about everything else. Just think about what is the resistor. Just think about this shaded region. Okay, this thin circular disc. Just think about that. What is the length? Okay, for this thin circular disc, what is the length? The length is going to be its thickness. And what is the thickness? The thickness here is dx. So in place of the length, I substitute dx. And then in place of the area, what would I substitute? It is a disc with a radius r. So what will be the area? The area is going to be pi r square. Is that correct? That is all I have done. And then we calculated the value of r and we substituted it over here. That's how we got the RHS. I hope that explains it. Okay? Perfect. So now let's go back to where we were. So we have put the limits of integration. Now all we have to do is integrate. Now you can understand that this is to the power of 2. Okay, and what we have here is we have a linear function of x. Can you see that? So what I can say is I can write it like this. Okay, I can say let alpha be, or to avoid confusion, I can just say that let beta is equal to b minus a upon L. Okay, just to make my calculation a bit simpler. You will see the integration, the form of integration in a much simpler manner. Okay, so let's see. So this becomes rho dx divided by pi, and this I can write it as a plus beta x square. Can you see that? So what is this? This is simply a linear function of x. Okay, so what I can do is I can take this upstairs and write it as a plus beta x to the power minus 2. Now do you recognize what is the integration from? It is simply x to the power n. Can you see that? So in place of x, what we have is a simple linear function of x. So that should not be a problem at all. So now we are in a situation to integrate this. Okay, so when we integrate this, what are we going to get? Rho upon pi is a constant. Now when we integrate this, we are going to get a plus beta x to the power. So minus 2 is there, so it will become minus 2 plus 1, which means minus 1 and then divided by minus 1. So I've integrated this, okay, in the usual manner, but my job is not done. It is a linear function of x. Remember, it's not x, it's a linear function of x. And what is the coefficient of x over here? The coefficient of x is beta. So we'll have to divide it by beta as well. So I'm going to divide it by beta as well. Is that correct? So what does this become? This becomes rho upon pi, and then this beta we can substitute now. Okay, we can substitute it back. So we are dividing it by beta. So this becomes L divided by B minus A. And then we'll take this minus sign out as well. So this minus 1 in the denominator. Let's take that out as well. And then we have A plus. And what is the value of beta? It is B minus 1 divided by L to the power minus 1. And then we'll have to put the limit of integration from 0 to L. Is that correct? Okay, so I hope the integration is clear. Let me know if the integration is not clear to you. Okay, it's a very straightforward integration. In place of x, we have a linear function of x, and that's all there is. Okay, so when we integrate it in the usual manner, but we divide it by the coefficient of x as well. Can you see that? Is that clear to you? Perfect. Let me know if there's any problem. All right. Now when this is done, now let's go and substitute the limits. Okay, so what are we going to get? We're going to get the resistance as minus rho L upon B minus A. And what do we have over here? So we have A plus B minus A divided by L to the power minus 1. Yeah, yes, Swastika, thank you for reminding me. This x will also be there. Obviously, this x is also going to be there. Thank you for reminding me, Swastika. So now we are going to write it over there. So remember, this is to the power minus 1. So we can take it in the denominator as well. So this is going to become 1 upon A plus B minus A divided by L into x. And now we have to substitute the limit from 0 to L. Is that right? So what is this going to be? This is going to be rho L upon B minus A. And then let's substitute L. Okay, so when we substitute L, what are we going to get? We're going to get A plus. Now in place of this x over here, we're substituting L. So L and L is going to get cancelled. So what are we going to be left with? We're going to be left with B minus A. Correct? So we've put the upper limit. Minus, now let's put the lower limit. Now in place of x, you put 0. This is going to become 0 and we'll be left with A. Is that right? So finally, what are we left with? We are left with rho L upon B minus A. And then this A and this A goes away. This minus sign, I can take it inwards. So this is going to become 1 minus A upon 1 minus B. And we can write it as rho L divided by B minus A. And this is going to become B minus A divided by AB. Okay. I think I missed the pi term somewhere. Okay. Not to worry. Yeah, I missed the pi term over here. I'm going to put that back. Just a constant, not going to cause any problem. Okay, so this B minus A and this B minus A is gone. Then what are we left with? We are left with rho L divided by pi AB. Okay, so what should be my answer? My answer should be R is equal to rho L divided by pi AB. Is that right? Any problems here? Let me know if anything, any part of this discussion was not clear. Alright, so I hope this is clear, and as we always do, we would rate the difficulty level of this question. Okay, we're going to rate the difficulty level of this question. It's a very typical kind of question. Okay, so here what we have is this shape is called a frustum, but tomorrow we can have a solid sphere, we can have a solid sphere with cavity, we can have different shapes, but the idea is the same. So you need to take the representative element, find the resistance for that, and then integrate it to find the total resistance. Okay, so this is one problem, but this kind of problem can be applied to many different places. Okay, so I hope this is clear. Okay, so the difficulty level, so Tanmay is saying it should be 4 out of 5, Jack Sparrow is saying 3 out of 5, and Shashank is saying medium, and that's fine. I'll say that this is medium difficulty level because there was a bit of calculation involved. Okay, but you can expect this kind of calculation. That's something that you should expect in your exam. Okay, you should be ready for that. Alright, so I hope that is clear. Now are you ready for the next question? Now let's go to the next question. Okay, so obviously the option C is going to be the correct option, and let's quickly go to the next question. Okay, now what we are talking about here is we are talking about circuits. Now all the preceding questions are going to be based on circuits. Okay, so let's look at this problem. Each of the resistors shown in the figure has a resistance of 10 ohm, and each of the batteries has an EMF of 10 volt. Find the currents through the resistors R1 and R2 in the following circuits. Okay, so you can look at the circuit. There are two batteries, they have EMF 10 volt each, and there are two resistors which have a resistance of 10 ohm each. So we have to find out what will be the value of current I1 and what will be the value of current I2. Okay, now this is a question on circuits, and before we proceed with solving this question, there are a few things I should tell you in order to approach any question on circuits. Okay, so whenever you have a question on circuits, don't just go on and try to solve that blindly. Okay, there has to be a strategy, and I want to discuss that strategy. Okay, so the circuit questions fall under few categories, and what we have to do is we have to prioritize. Okay, we have to see how do we go about figuring out that what kind of circuit is it. So whenever you get a circuit, the first thing you should do, okay, I'm going to write it over here, you can note it down as well. The first thing you should do is you should be able to, or you should try to find out if there is a parallel or series combination somewhere. Okay, so the first thing you should try to figure out is there a parallel or series combination in this circuit. Okay, if you are not able to figure that out, then you should look for Wheatstone bridge. Okay, there might be a Wheatstone bridge hidden somewhere. Okay, so if you are not able to find series parallel, then you go for Wheatstone bridge. Try to figure out if there is a Wheatstone bridge hidden over there. Okay, if you are not able to find out Wheatstone bridge, then what should you do? You should go for symmetry. Okay, there are different kinds of symmetry, but the purpose of symmetry is one, to find out equipotential points. Okay, many different kinds of symmetry, path symmetry, okay, longitudinal symmetry, horizontal symmetry, many different kinds of symmetries, but the crux is one. You have to find out the equipotential points. So you should look for symmetry in the circuit. And if you are not able to find symmetry in the circuit, and let's say you have multiple batteries, okay, if you have multiple batteries, then you can look at combination of cells. So it may happen that the circuit looks very complicated. It has multiple batteries. So if you are not able to find any of the above things, then you should look for combination of cells. It may happen that the cells are in series or parallel combination. Okay, and if you are not able to find out any series combination of cells, you are not able to find series or parallel combination of cells, then there is another very interesting concept, and that is superposition. It might happen that you can apply superposition and solve this question. Okay, in superposition, what do? You short one battery, okay, you short circuit one battery, find the current. You short circuit another battery, you find the current, and the net current in that branch is going to be the algebraic sum of those two currents, and you'll have to take care of the direction as well. Okay, so another thing you should look at is superposition. And when everything fails, you cannot find any of these things, then your final resort is KCL KVL. Okay, your final resort is KCL KVL. Okay, don't start with KCL KVL. Okay, it's the last resort that you can go to. Okay, Tanmay is saying Thevenin's theorem. True, Tanmay, you can also apply Thevenin's theorem, but in JEE it is not in syllabus, and mostly the questions that you get in JEE, you can solve those by easier methods than Thevenin's theorem. Thevenin's theorem is obviously one resort, but it's not really important. I won't suggest to go very deep into it, because obviously the questions are meant to be solved by simpler methods. Okay, so this is what you need to follow. All right, and this is what we're going to follow in this session. Okay, so we have the circuit over here. Now can you tell me what should we apply here? Okay, is there any series combination? Okay, can you tell me if there is any series or parallel combination over here? What does parallel combination mean? It means that the two elements should be between the same points. Okay, so if we talk about these two resistors, it is between A and B, and this resistor R2 is between A and C. So obviously this is not a parallel combination. How do we look at series combination? Okay, how do we look at series combination? So what we need to do is we need to go from one element to the other element and see if there is branching or not. Okay, so let's talk about R1. So what we are going to do is we are going to go from R1 to R2, but what we find over here is there is branching. If there were no branching, then these would have been in series combination, but because there is branching, these are not in series combination. Okay, obviously we don't have enough resistors for Wheatstone bridge. We don't find any symmetry over here. So what we understand from here is that we cannot apply any of the other methods. Okay, so our last resort is to solve it using KCL and KVL. Is that right? Okay, are you convinced? Perfect. So now, and because this is a very simple question, we could have used combination of cells, but in this particular question, the question is so simple, the circuit is so simple that if you apply KC and KVL, it is going to be much faster. Okay, in more complicated circuits, combination of cells is going to be very handy. Okay, so now let's look at this. So what we can do is we can think about going in this particular loop. So we are going from this point to this point to this point to this point. Okay, we can go in this loop, and let's say we are starting from A. We are starting from A in this circuit and we are going clockwise. So what do we see? So when we encounter this battery, we are going from the negative terminal to the positive terminal. So obviously what will be the change in potential? The change in potential is going to be positive. We are going from the negative terminal to the positive terminal. What does it mean? It means that the change in potential is going to be positive. So what are we going to write? We are going to write plus 10. Agreed? Okay. Then we are going from here to here. So we are going across the resistor, and what we have done is this is the current we have assumed. Okay, this I1 is the current in the branch we have assumed. Okay. Now we are going in the direction of the current. Can you see that? We are going in the direction of the current. And when we are going in the direction of the current, the potential is going to increase or decrease. When we are going in the direction of the current, then obviously the potential is going to decrease because the current flows from higher potential to lower potential. So in this case, we are going to write minus I1 R1, and then we are back over here, and this is going to be equal to 0. Tanmay is asking, will the direction of current will be given? So in the question, the direction of current is given, but if it is not given, then we can assume. It does not matter what direction of current you choose, but it is important that you apply KCL and KVL accordingly. Is that right? Okay, so we assume the direction like this. So we are writing KVL as per the direction we have assumed. Okay, so once you have assumed the direction, don't mess it up. Perfect, that's all we need to do. So from here, what do we get? From here, we get the value of current as 1 ampere. Can you see that? The value of current comes out to be 1 ampere. And since the value of current has come out positive, it means that the direction we have chosen for the current is the right direction. Okay, so we have figured out what is this current I1. This current I1 is 1 ampere. Okay, similarly, what we can do? We have to find out this current I2. So what we can do is we can go in a loop like this. Okay, and we can choose to go clockwise. Can we do that? Of course we can do that. Okay, and the direction of current I have assumed like this. Okay, you can assume it in the opposite direction also, but just be careful to write KVL according to that. Perfect. So this is what I have assumed. Now I'm going to write KVL. Okay, so I'm going to start from here. Now when I start from here, I'm going to go from the negative terminal of the battery to the positive terminal. So I will have to write plus 10. Now I'm here. Okay, now I'm going across this battery. So now across this battery, I'm going from the positive terminal to negative terminal. So this is going to become minus 10 because I'm going from positive terminal to negative terminal. Okay, now where am I? I'm over here. Now notice I'm going in the direction of current. What is the direction of current? Like this. I'm going in the direction of current. Okay, so now what should I write? I should write minus I2 R2. Is that right? I'm going in the direction of the current, so the potential I have to write it as minus I2 R2. Okay, and then I'm back over here. So when I have gone through the entire loop, this should be equal to 0. So this 10 and this 10 is gone, so I2 comes out to be 0. Is that correct? Alright. So I hope this is clear. So what is going to be my right answer? The right answer is going to be I1 is equal to 1 ampere, I2 is equal to 0 ampere. Is that clear? Okay, any problems here? So as always, we want to figure out what is the difficulty level for this problem. Okay, so quickly let me know what do you think is the difficulty level for this problem? Yes, Captain Jack Sparrow is absolutely correct. No current. Can we choose inner loop? Okay, so Shashank is asking, can we choose inner loop? Yes, Shashank, you can choose any loop you want. Okay, and I can show that to you as well. You can choose any loop you want, does not matter, as long as you are writing the KVL properly. So I'm going to show it to you, no worries. Okay, so what we are going to do is we are going from this point to this point, to this point, to this point, to this point, and back over here, and we are going to go clockwise. Okay, that's what we are trying to do. Okay, let's start from A. Okay, let's start from A. So we are going in this direction, and the current we have assumed is in the opposite direction. Can you see that? I1 is in the opposite direction, and we are going opposite to the current. So when we are going opposite to the current, we should write plus I1 R1. Do you agree? Okay, so we have gone opposite to the direction of current, so we are going to write plus I1 R1. Then where do we reach? We are crossing this battery from the positive terminal to the negative terminal, so we should write minus 10. Now we are crossing this resistance, and we are going from in the direction of current. Okay, so in the direction of the current, this should be minus I2 R2, and then we are back, so this should be equal to 0. Do you agree? So I have written KVL as per the directions I have assumed. Okay, now did we already calculate I1? We already had calculated I1, that was 1 ampere. So 1 into 10 is going to be 10, minus 10 minus I2, and R2 is 10. This should be equal to 0. This is gone, and I2 comes out to be 0. So there is absolutely no problem in choosing any loop. You can choose any loop you wish, just apply KVL properly. That's all we need to take care of. Alright, so the question, some people are rating 0.5, some people are rating 2, some people are rating 3.5, so it's a very controversial over here, but I'm going to put it in the easy category. Okay, I'll give it 1 to 2 as the difficulty level, because it's simple application of KVL and KCL. Okay, Tanma is asking, sir, can you please explain superposition theorem very briefly? Alright, that is, I had not planned for it, but sure, I'm here to help you. So no matter how much time it takes, I'll try to clear all your doubts. Okay, and this is a very interesting way to solve problems as well. Okay, it's a very interesting way to solve problems. So sure, let's try to do that. Okay, now in superposition principle, what we do is we short the battery. Okay, we short the battery one at a time. And when we short the battery one at a time, simply what happens is, if you short anything, if you short circuit anything, what does short circuit mean? It means that we are joining the terminals of this battery. Okay, I'm shorting this battery. If I'm shorting this battery, what does it mean? That it is going to provide it a zero resistance path. And if it is providing it a zero resistance path, then no current is going to flow through this battery. Okay, so you short any element, okay, be it a resistor, be it a battery. If you're shorting it, it simply means that no current is going to go through it, and you can take that element and throw it out of the circuit. Okay, so when I have shorted it, what I have done is I will take this element and throw it out of the circuit. So just forget about this part of the circuit. I've shorted it. So I've shorted the first battery. Okay, now when I've shorted the first battery, what I see here is that this R1 and R2, forget about this I2 for now, this R1 and R2 now are in series combination. Can you see that? R1 and R2 are in series combination. So can I find what is I1? Very simple. This is 10 volt and this is 10 ohm and 10 ohm in series, which makes it 20 ohm. So what is the current? The current is going to be 10 divided by 20, which is 0.5 ampere. But don't forget the direction of current. The direction of the current is going to be from left to right. Can you see that? The direction of current, sorry, from right to left. The direction of the current in R1 is going to be from right to left. Can you see that? That is the direction of I1. Agreed? Clear? I hope that is clear. So our shorting job for first battery is done. Okay. Now let's bring it back. And And now what we're going to do is we're going to short the next battery. Okay, so when I short this battery is non-existent for me. Okay, so it is not going to serve any purpose for me. So I'm going to throw it out of the circuit. Is that clear? Okay, so now when I throw it out of the circuit, so basically what happens? Okay, if I throw this battery out of the circuit, then what are we left with? We are left with the same thing. Okay, so we are left with this loop over here. We are left with this loop. Is that right? Okay, now when we are left with this loop again, so this is going to go something like this. Okay, so this is going to go something like this. We have shorted it. Okay, so this loop is going to go, this loop is going to go something, so we have shorted this battery over here. So this battery is not going to be in existence, so we can get rid of this battery. And so alright, so there's going to be no current in this branch. There's going to be no current in this particular branch. Okay, so what we are left with is, we are just left with this over here. Okay, we are just left with this current over here. So this, perfect. So this point, these 2 points. Alright, so what now is going to happen is, we have this over here. These 2 points are going to become the same, and these 2 points are going to become the same. Okay, so now what is going to happen is, these 2 resistors are now going to be in parallel. Okay, so these 2 resistors are now going to be in parallel. So what is going to happen is that the current I1 over here, and I should write the current over here. Let's write it as current over here. This is a different current. Okay, we'll distribute it later. So these 2 points become the same, these two become the same, so this becomes parallel combination, and then we have this current coming out of the battery. So in parallel combination, what is going to happen? R1 and R2, this is going to become 10 ohm and 10 ohm, which is going to give me 5 ohm. Is that correct? So it is going to give me 5 ohm. So this current through the battery is going to become 10 divided by 5. So that is going to give me 2 ampere. And when I distribute this current, okay, so both this current is going to get distributed equally, and when I distribute this current through this is going to become 1 ampere. Okay, so through this resistor I1, it is again going to become 1 ampere. Okay, so my answer should be 1 ampere, and through I2, if we do the same exercise and find I2, we are going to get that again. Okay, so when we short one battery, we are going to short this battery, we are going to get the current as I2. Okay, yes, absolutely. So in this particular question, it's slightly more tedious to apply it, so that superposition principle is going to be applied much better if we have multiple batteries. Okay, if we have a more complicated circuit, so in that case superposition principle is going to work well. But in this situation, when the situation is very simple, then it's better to apply KCL and KVL if you are not able to find out what is the symmetry, if you are not able to find any of the symmetry or series parallel combination. We are going to discuss symmetry when we get to the questions, so Umar, don't worry about that, we're going to do that. Alright, so the correct option for this question is going to be option B, and now let's move to the next question. Alright, now let's go a little bit faster because we have to go look at a lot of questions. Okay, so in this situation, the situation is the same. The potential difference of the battery, the EMF of the battery is 10 volt, and the resistances are 10 ohm again. Okay, now in this case, we have to find out I1 and I2. Okay, now let's look at this. So again, are you able to see any series combination in the circuit? Are you able to see any series combination? Okay, I cannot see any series combination. I can also not see any parallel combination or any symmetry. So the last resort is to use KCL and KVL. So what we are going to do is we are going to apply it in this one. Okay, but it's not always necessary to apply it in a way that we have seen. Okay, now think about this. It's very simple. Now just think about this resistor. What is the potential difference across this resistor? The potential difference across this resistor is 10 volt. Okay, just don't think anything else. Just think at the two terminals of the resistor. So what is the potential difference across the two terminals of the resistor? It is simply 10 volt. Okay, now if this is 10 volt, then what is the current that is going to come? The current through this part is going to be how much? It is simply going to be 10 volt divided by 10 ohm, which is how much? Which is 1 ampere. Can you see that? We don't have to apply KVL over here. What we can see is that across the two terminals of the resistors, the potential is 10 volt. So what will be the current? The current is going to be 10 by 10 divided is equal to 1 ampere. Now 1 ampere is going to flow from here. 1 ampere is going to be flowing over here. Okay. Now 1 ampere comes from the battery. 1 ampere flows through the resistance, which means what will be the current over here? Can you apply the junction law? Okay, if you apply the junction law, what you can see? That 1 ampere is coming, 1 ampere is going. So will there be any current in I2? There is going to be no current in I2. Is that right? So for I1, my answer is going to be 1 ampere, and for I2, my answer is going to be 0 ampere. Is that correct? Okay. Perfect. Is that clear? Okay, so what will be the correct option? The correct option to this question is going to be option B. Okay, so the purpose of these two questions was to make you understand that what is the process we need to follow. Okay, what are the things we need to look at, and when we don't find anything, we don't find series parallel combination, we don't find symmetry, we don't find Wheatstone bridge, then only the final resort is KCL and KVL. Okay, perfect. Now let's move to the next question. I'm not asking to rate this question because it is going to fall in the easy category, and that's the response I'm going to get. So let's move ahead. Alright, so let's look at this question. Now we have to find out the equivalent resistance between points A and B as shown in the figure. Okay, so this is the network which is shown, and we have to find out what is the equivalent resistance between points A and B. Okay, so what is the first thing we should look at? We should look at series and parallel combination. Are you able to spot the series and parallel combination? Let me know. Can you figure out that do we have any series and parallel combination over here? Good evening, Prasad. Captain Jack Sparrow, symmetry. The first thing we need to see is series parallel combination. If we are not able to find series parallel combination, then sure, then symmetry is something we'll have to look at. But first we have to be sure if we don't find any series and parallel combination. So is it the case, or we are able to find series and parallel combination? Okay, so Tanma is saying yes, sir, both. Absolutely. Okay, so let's look at this. So this is a 4 ohm resistor, this is a 2 ohm resistor. Let's go from the 4 ohm resistor to the 2 ohm resistor. Do we see any branching over here? No, there is no branching over here, which means 4 and 2 are in series combination. Is that right? Now if 4 and 2 are in series combination, can we change this circuit? So instead of this 4 and 2, I'm going to merge them into one. Okay, we are going to merge them into one. And the series combination of 4 and 2 is going to be how much? It is going to be 6 ohm. Can we say that? Okay, I'm saying that again. We have a 4 ohm resistor over here. We have a 2 ohm resistor over here. They are in series combination. So 4 and 2 is going to give me how much? They are going to give me 6. Okay. Now when they are going to give me 6, I can merge these two resistors and write just one resistor. So I am forgetting about this and I'm making this 6 ohm. Do you have any problem with that? I hope that is clear. Now we have this 6 ohm resistor and this 3 ohm resistor. Now this 6 ohm resistor is between these 2 points, and this 3 ohm resistor is also between the same points, which means they are in parallel. So I have to find what is the equivalent resistance of 3 and 6. Okay. So how do we do that? In parallel combination, we are not going to write 1 upon R1 plus 1 upon R2, etc. We are simply going to write R1 R2 upon R1 plus R2. It's faster. When there are 2 resistors, this method is faster. So R1 into R2 is going to give me how much? It is going to give me 3 into 6 and divided by 3 plus 6. So this is going to give me 18 divided by 9. So this is going to become 2 ohm. Do you agree? Perfect. So this 6 ohm and this 3 ohm I can again merge together and make it 2 ohm. Okay, so now what I have to do is I have to forget about this also, and this is going to become 2 ohm. Correct? Okay, now what do we have? We have this 4 ohm and this 2 ohm, and this is going to make it 6 ohm. So again I can forget about this and I can write it as 6 ohm. And then we have this 6 ohm and this 3 ohm, they are again in parallel. So everything is repeating itself. And we have already seen what is the parallel combination of 6 and 3. It is 2. So again I can forget about this and I can write this as 2 ohm. And finally what do we have? We have this 4 ohm and this 2 ohm in series, and then that is the resistance across A and B. So what is going to be the equivalent resistance? The equivalent resistance now for the entire circuit between points A and B is going to be 6 ohm. Okay, and that should be my answer. Alright, so a lot of you are in the habit of redrawing the circuit. Please don't do that. Be a little smarter than that. Okay, you are in the habit of redrawing the circuit. So once you have taken series, then you are going to redraw it. Then you have taken parallel, then you are going to redraw the circuit. Great, but you cannot afford that in an examination. Alright, so just keep crossing over and do it on the same question. Okay, it's not that difficult at all. Is that clear? Okay, so obviously this question is going to fall in which category? I should not ask you. But still, if you have to rate it, what are you going to rate for this question? Tanmay is saying it's very easy. Yes, I completely agree. This is going to fall in the easy category. Okay, so this is a very typical kind of question you get in JEE Main. Okay, all you have to do is spot series and parallel combination and keep evaluating or keep figuring out the equivalent combination. Okay, that's easy. Alright, so the correct option for this question is going to be option D, and yes, I take 1 out of 5, 2 out of 5. The point is, this is going to fall under easy category. Okay, now we have another question over here. Now the first thing I'm going to ask you is, what is the method that we should use to solve this circuit? Now you figure it out on your own and tell me what is the method we should use to solve this circuit. Whether we should use series parallel combination, whether we should use Wheatstone bridge, whether we should use symmetry, or finally, if nothing is there, we have to use KCL or KVL. Now you figure out and tell me what is the method we should use to solve this question. Once you have spotted what is the method you have to follow, then that becomes very easy. But the main idea is to spot what should you use. That is the main objective of this question. Captain Jack Sparrow says series combination between AFE. Yes, you are absolutely right. There is a series combination between AFE. Anish has got the answer as well. Anish is saying option A is the answer. Alright, we'll check. Great. Any other suggestions? Alright, so you guys have given me the answer itself. So that tells me that you have already figured out how to solve this circuit. Okay, and the answer is there is series and parallel combination over here. Okay, you have to do reduction of the circuit using series and parallel combination. Absolutely right. Shashank, you're absolutely right. So the first thing we see here is that we have this resistor and this resistor in series combination. Do you agree? We have these two resistors in series combination. Alright, let's solve it over here. So we have this and this in series combination. So 3 and 3 is going to make 6. Okay, 3 and 3 is going to make 6. So I can get rid of this resistor and simply write it as 6 ohm. Do you agree? Okay, now what do we see? We see 6 ohm and 6 ohm, and they are in parallel. They are between these 2 points. Can you see that? Both the resistors are between E and A. So what is it? It is going to be a parallel combination. So if we take a parallel combination of 6 and 6, it is going to be 3. Okay, let's not do that again. Let's remember this result. So 1 upon R equivalent is equal to 1 upon R plus 1 upon R. So if we have resistors with equal resistance and they are in parallel, then the equivalent resistance is going to become R by 2. Okay, so 1 upon R eq is equal to 1 upon R plus 1 upon R. This is 2 by R, so R eq is equal to R by 2. Okay, we should remember this result. So if we have two resistors, with the same resistance in parallel combination, the equivalent resistance is going to be half. That's it. So 6 and 6 is going to add up and make how much? It is going to make 3. Okay, so I can forget about this and I can make this 3 ohm. Now this 3 ohm and this 3 ohm again is in series. So I can forget about this and I can make it 6 ohm. Now this 6 ohm and this 6 ohm, you can see this is again in parallel. So 6 and 6, again it is going to give me 3. So I can get rid of this and make this 3 ohm. And the story is repeating itself. That's what is happening. So this 3 ohm and this 3 ohm, again they are in series. They're going to make 6 ohm. So I can get rid of this. I can write this as 6 ohm. And 6 and 6 again in parallel. So we can get rid of this. We can write this as 3 ohm. Now this 3 ohm and this 3 ohm again is in series. So we can get rid of this and we can write this as 6 ohm. Okay, but now careful. Okay. Now this 6 ohm is between points B and, so this 6 ohm is between, so this is going to be joined to this. So this 6 ohm is between A and B. Can you see that? This 6 ohm resistors is going to be between A and B, and this 3 ohm resistor is also between A and B. Okay, so now here, just be a little bit careful. This is going to be in parallel combination. Okay, so the parallel combination of 3 and 6 is going to be how much? Very simple. Req is going to be R1 R2 upon R1 plus R2. So this is going to be 3 into 6 divided by 3 plus 6, and that is going to give me 2 ohm. Okay, 18 divided by 9 is 2 ohm. Is that clear? Okay, so what will be the correct answer? The correct answer for this circuit is going to be 2 ohm. So Captain Jack Sparrow is saying, I think Wheatstone bridge is between A and EDC. Okay, it may happen, Captain, that you can get a Wheatstone bridge in between, but the thing is that the first thing you should look at is series parallel combination. If you are getting series parallel combination, then just carry on with it until you are not able to apply series parallel combination, because that is going to be much simpler, right? So if we get stuck somewhere, then we should look at Wheatstone bridge. It may happen that there is a Wheatstone bridge in the circuit, but what we see here is that by reducing it using series parallel combination, we can do that much faster. Umar is asking, sir, हमें फिगर की किस साइड से स्टार्ट करना है ये सीरीज एंड पैरेलल कॉम्बिनेशन? उमर, जिधर मिल जाए अपने को सीरीज पैरेलल कॉम्बिनेशन, तो ये तो देखना पड़ेगा, हमें देखना पड़ेगा. ऐसे कोई रूल हम नहीं बता सकते हैं, तो ऐसे हमको देखना पड़ेगा कि कौन सीरीज पैरेलल कॉम्बिनेशन में है. ये तो प्रैक्टिस से आएगा. ठीक है, अगर फिगर के राइट साइड में देखोगे तो ये जो 3 ओम है और ये जो 3 ओम है, क्या ये सीरीज कॉम्बिनेशन है? नहीं, ये तो ब्रांचिंग हो जा रही है यहाँ पे, तो ये सीरीज कॉम्बिनेशन नहीं है. ठीक है, कहीं पे इधर पैरेलल कॉम्बिनेशन मिल रहा है क्या? कोई भी ऐसा रेजिस्टर नहीं मिल रहा है जो सेम पॉइंट्स के बीच में है. ठीक है, तो ऐसा हम कह नहीं सकते हैं कि किस साइड से शुरू करना है, वो हमको देखना पड़ेगा. तो और जिस साइड से मुझे दिख रहा है सीरीज कॉम्बिनेशन या पैरेलल कॉम्बिनेशन, उस साइड से स्टार्ट करना पड़ेगा. तो इस साइड से मुझे क्लियरली दिख रहा है, इसलिए मैंने इस साइड से स्टार्ट किया. ठीक है, ऐसा कोई रूल नहीं बना सकते हैं. ठीक है, ऑलराइट, सो आई होप दैट इज क्लियर. अगेन, दिस इज गोइंग टू फॉल अंडर इजी कैटेगरी, but the idea is to identify, once you have identified its piece of cake, but the idea is to identify what kind of circuit is it. Okay, so that's great, we have done that. So option A is going to be the right option. All right, now let's move to the next question. Find equivalent resistance between points A and B. Okay, now this is A, this is B, and we have to find out what is the equivalent resistance between A and B. Now my question to you is, what kind of circuit is this? What should we apply in this circuit? सीरीज पैरेलल है, व्हीटस्टोन ब्रिज है, सिमेट्री है, केसीएल केवीएल लगाना पड़ेगा, क्या करना पड़ेगा? Let me know. What do you think should be applied over here? Okay, Anish is saying Wheatstone bridge. Shivam is saying Wheatstone bridge. Tanma is saying Wheatstone bridge. Any other guesses? Tanma has changed his answer. Now he is saying KCL. Okay, Anish is now saying not Wheatstone. Captain Jack Sparrow is saying KVL. KVL or KCL. Okay, Vaibhav is saying Wheatstone bridge. Right. I understand the confusion over here. I absolutely understand the confusion here. Your confusion is absolutely legit. A lot of people are going to have this confusion in this particular question. Okay? Now listen carefully. This looks like a Wheatstone bridge, but it is not a Wheatstone bridge. Okay? So what we do is we divide this resistor by this resistor. We take the ratio of this resistor and this resistor, and we take the ratio of this resistor and this resistor. Okay? Now the ratio here is 2. 10 upon 5. What is the ratio? The ratio here is 2. And the ratio here is 5 divided by 10. The ratio here is half. Okay? So this is not Wheatstone bridge, although it is very tempting to think it is Wheatstone bridge. But this is not Wheatstone bridge. Let's be very clear about that. Okay? So I'm repeating myself. So R1, R2, R3, R4 are arranged in this order. This resistor is between the bridge. But we have to take the ratio of this resistor to this resistor, which is 2. Now we cannot take this upon this. Okay, that order has to be maintained. So we'll have to take this ratio divided by this ratio. I'm sorry, this resistance divided by this resistance. That is half. So this is not Wheatstone bridge. Okay. So if this is not Wheatstone bridge, obviously there is no series and parallel combination that you can see. Okay, series and parallel combination is not over here. You look at this resistor. Now if you go from here to here, there is a branching. Can you see that? Or if you go from here to here, there is a branching. So this is not series combination. Now this resistor is between these 2 points. This resistor is between 2 points which are different. This is not parallel combination either. You can't find any parallel combination here as well. Okay. Now this is a very different kind of symmetry. It's a very special kind of symmetry. And let me try to make you understand this symmetry. Okay. And symmetry, I cannot really make you understand. Symmetry has to be felt. Okay. Symmetry is very difficult to make you understand. Symmetry has to be felt. But I'll try my best to make you understand this. Okay. So in this situation, what I'm going to say is, you rotate this circuit by 180 degree. Okay, you rotate this circuit by 180 degree and see what happens. Okay, if I rotate this circuit by 180 degree, I've literally rotated it by 180 degree. Now can you tell me, has the circuit changed? Has the circuit changed? Compare the two circuits. So this circuit, I have rotated it by 180 degree and then I get this circuit. Okay. Has the circuit changed? Is there any difference between the two circuits? And the answer is no. Okay. The answer is no. There is no difference between these two circuits. Okay. So what it means is that if I send current through A, there will be some current coming out of B, okay, and the circuit is going to be distributed like this. The current is going to be distributed in various branches. But what if I send current through B, then the same current is going to come out of A, and the circuit distribution and the distribution in various branches, distribution of current in various branches is going to be the same. Can you say that? So if I send it through A and collect it out of B, or I send it through B and collect it out of A, the circuit, the current arrangement or the distribution of current in each branch is going to be exactly same. Can you say that? Can you understand that? Can you appreciate that? I'm going to say that again. If you send current through A and you collect it out of B, or you send current through B and collect it out of A, in both the situations, the current in various branches is going to be exactly the same. Do you agree? Okay? So now we are going to use this concept to solve this question. Okay. So what I'm going to say here is, or what I'm going to argue over here is, let's say that current I has been sent. Okay. Current I has been sent through A. So obviously after all this branching and rebranching and rejoining has been done, current I will be coming out of B. That's pretty obvious. Okay. That's simply junction law. Okay. So I'm sending current I through A. So obviously I'm going to get current I through B. Is that perfect? Okay. Now here we have 10 ohm, here we have 10 ohm, here we have 5 ohm, here we have 5 ohm. Okay, this is the symmetry we are seeing. So if current I1 goes over here, what current is going to go here? Current I minus I1 is going to go here, correct? If current I1 is going here, current I minus I1 is going to go here. Now what basically I'm doing is, suppose there are two people, okay, suppose there is Shashank and there is Tanmay, okay. I have given 20 rupees to Shashank and I have given 10 rupees to Tanmay, okay. Now it is the time to take back my money, okay. So whatever money I have given, I'm going to take it back. So I had given 20 to Shashank and I had given 10 to Tanmay. Now when I'm collecting it back, what I'm going to do? I'm going to collect the same amounts. So I'm going to collect 20 from Shashank and I'm going to collect 10 from Tanmay. Does that make sense? Okay. So the amount of money I had given to each person, when I'm taking that money back, I'm going to take the same money back. Okay. I cannot ask Tanmay for 20 rupees because I had given him 10 rupees. Correct? That's exactly the situation over here. You had given this 10 ohm resistor I1 current. Now when you are taking this back, when you are collecting this current back, then you are going to collect I1 only. You cannot collect more or less. When you have given this resistor I minus I1 current, you are going to collect this same I minus I1 current back. Okay. And this is how this is going to work. So the current in this resistor and the current in this resistor is going to be the same. The current in this resistor and this resistor is going to be the same. Okay, this is the symmetry argument that we can apply to reduce the number of variables. So how many variables do we have? We have I and I1. If we had not used the symmetry argument, then we would have taken 4 variables. In that case, we would have to take 4 variables and then solving it using KCL and KVL would have been a task. Is that clear? Okay, so using this symmetry argument, what we have said is that the current in the 10 ohm resistors is going to be the same, the current in the 5 ohm resistors is going to be the same. Now we can apply KCL and KVL and it is going to become simpler. Okay, now we can apply KCL and KVL. Okay, so what is going to be the current through this branch? So this is going to be I1 plus, let's call this I3 or let's call this I2. So applying junction law over here, I1 plus I2 is going to be equal to I minus I1. So I2 is going to be how much? It is going to be, sorry, I have not applied that correctly. So I1 is coming in. So this should be I minus I1 plus I2. So I2 should be 2I1 minus I. Okay. So the current here is going to be 2I1 minus I. Captain Jack Sparrow is asking, is there no current through 5 ohm in between? No, there is obviously there's going to be a current. That's exactly what I found out. I've used the junction law over here. And I found out the current is going to be 2I1 minus I. Okay. So what is the current coming into the junction? The current coming into the junction is I1 and the current going out of the junction is I2. This current I have chosen as I2 plus this current over here I minus I1. Okay. So I have figured out what is I2 and what is I2. It is 2I1 minus I. Now I can apply KCL and KVL, but there is a special way of applying KCL and KVL because we have to find the equivalent resistance. We'll have to connect these two ends with a battery. Okay, so we have connected these two with a battery with potential difference V. Is that correct? Okay. Now what we have to do is we have to apply KCL and KVL, and what we have to find out is we have to find out V by A, because the current supplied by the battery is I and the potential difference is V. So V by I is going to give me the resistance, which in this case is going to be the net resistance. Alright, so let's go for it. So I'm going to go clockwise in this circuit. Okay, which circuit? Let me show that to you clearly. I'm going from here to here to here to here. That's what I'm going to do. Okay, so let's do that. Okay, let's go in this fashion. So I1, so I'm going like this, which means I'm going in the direction of the current. So if I'm going in the direction of the current, it is going to be minus 10 I1. Now again here I'm going in the direction of current, which means I have to write minus 5 into 2 I1 minus I, and then here I'm going opposite to the direction of current. Can you see that? So I'm going to write plus 5 into I minus I1, and then I have reached back to the same point. So this should be equal to 0. Alright, so if you want me to name the points, sure, I'm going to name the points if that is going to make it easier. Alright, let me do that again, don't worry. Okay, So I'm going to go from, let's call this A to B to C to D and back to A. Okay, this is what I'm going to go for. A, B, C, D, A. And I'm going clockwise. Okay, let's start. So first I'm going to start with A. So I'm going to encounter this 10 ohm resistor. So this is going to be, I'm going in the direction of current. So I'll have to write minus I into R. So this becomes minus 10I1. Now what is happening? Now I'm going like this. I'm again going in the direction of current. So I'll have to write minus 5 into 2I1 minus I. And now I'm going from C to D, which is opposite to the direction of current. The direction of current has been like this. This is what I've assumed. Now I'm going opposite to the direction of the current. So I'm going to write plus 5, and this is going to be I minus I1. And then I'm back at D and I'm back at A. So this is going to be equal to 0. Is that correct? I hope now it is clearer. Okay. Alright, so now let's simplify this. So this is going to become minus 10I1 plus 5I plus 5I minus 5I1 is equal to 0. So let's correct all the I1 terms. So I'll have 25I1. So I'll get 25I1 is equal to 10I, and this is going to give me 5I1 is equal to 2I. This is going to be my equation number 1. Is that clear? That is going to be my equation number 1. Okay, if this is clear, I want to erase this so that we can go to the second loop. Okay, I'm going to erase this so that we can go to the second loop. Is this clear? If you want to note it, I'm going to give you a few seconds to note this down if you want to. And then I'm going to rub this off and go to the second loop. Alright, so let me erase this. All right. Okay. Now the circuit I'm going to go for is, I have to involve the battery. Okay, because I need V by I. My objective is to find V by I. So I'll have to involve the battery. So now what I'm going to do is, I'm going to go in this fashion. I'm going to go from A to B. Let's call this E. And then let's call this F. And then back to A. Okay, so the loop I'm taking is, going from A to B to E to F, and then through this battery. Okay, through this battery, I'm going back to A. Is that clear? Is the loop clear? A to B to E to F, and then through the battery back to A. Okay, this is the loop I'm going to follow. So let me write the second equation. If I write the second equation, I'm going to start from A to B. Okay, A to B, how am I going? I'm going in the direction of current. So it is going to be minus 10I1. Then I'm going from B to E. From B to E, I'm also going in the direction of current. Okay, so this is going to become minus 5 into I minus I1. Now E to F, there is nothing. Now F through this battery. Now I'm going through this battery, and I'm going from the negative terminal to positive terminal. So I'll have to write plus V. Okay, and then I'm back at A. So our loop is complete. So this is going to be equal to 0. So then what do I get? I get minus 10I1, and then I'll have minus 5I1, and minus 5I plus V is equal to 0. I get this as the second equation. Okay, now I can simplify this equation. So this is going to become minus 10I1 and minus 5I1. So this is going to become minus 15I1, and then I have minus 5I. Okay, so I'm going to take it over here, and this is going to become V is equal to minus 15I1 minus 5I. And we have already taken the relationship between, we have already found out the relationship between I1 and I. So I can substitute I1 as 2I by 5. Okay, I can substitute I1 as 2I by 5, and then we have minus 5I. This is okay. So for I1 I have substituted 2I by 5. So what are we going to get? Okay, so this is going to become plus. I'm sorry, this is going to become plus. I've taken it to the other side. So this 5 and this 3, this is going to become V is equal to 7I. Can you say that? 5, have I made a calculation mistake somewhere? Let me go back and check. So this is minus 10I1, and then we have minus 5 into I minus I1, and then we have come over here, and then we have plus V. So we have minus 10I1 minus, oh, so this should be plus 5I1. I am so sorry about this calculation error. We should never make. Okay, so this is going to become minus 5I1 minus 5I. Okay, let me go back over here, correct myself. So this becomes 5I1 plus 5I. Okay, let me check that again. I hope I'm right. Okay, and then for 5I1 I can substitute 2I. Okay, for 5I1 I can substitute 2I. So for this 5I1 I am substituting 2I. So this becomes 2I plus 5I, so V becomes 7I, and my objective was to find V by I, and that is going to give me 7 ohm. Is that correct? Okay, so what I have done is I have connected it to an external battery with a potential difference V, and I'm saying that the battery has provided a current of I, which means that V by I is going to give me the equivalent resistance. Okay, so the equivalent resistance is going to come out to be 7 ohm, and that is going to be our answer. Alright, so I hope that is clear. This was a tricky question. Okay, make no mistake, this was a tricky question because we often mistake it as Wheatstone bridge, which is not the case. It is a very different kind of symmetry which I explained it to you. Okay, so what should you think? What do you think is going to be the difficulty level for this question? Quickly let me know. Shivam, this is the easiest method to solve this question. I'm afraid the other methods, there are other methods, but using this symmetry argument is the easiest method to solve this question. Okay. Alright, so option B is going to be my right option, and then let's quickly go to the next question. Okay, this is very famous question. Okay, you'll find this in every book, but using this question, what I want to show you is how do we use symmetry. Okay, you can understand from this figure that this is something to do with symmetry. So obviously we need to solve it using symmetry. Okay, Tanmay is asking, can we use star delta symmetry? Tanmay, you can use star delta symmetry. Sure, you can use it, but again, in these questions, it is not going to be very helpful. Okay, in these kind of questions, it's better to go with what we know. Because the examiner has a mindset when they are setting the question, they have a mindset. Sure, you can use star delta, but according to me, it's not very helpful in these kind of questions. Alright, now let's talk about this. So we see symmetry. Okay, obviously we see symmetry over here. But can you tell me what kind of symmetry are we seeing? What is the argument that we can present? What is the step that we need to follow? What kind of symmetry do we see here? Can you name the symmetry, or at least try to explain the symmetry? What kind of symmetry do we see here? Okay, so what we see here is path symmetry. Okay, you take any path from A to B. Okay, you take any path from A to B, all paths are symmetrical. Whether you go from this point to this point, to this point to this point, or you go from this point to this point to this point to this point, or you go from this point to this point to this point to this point, all are same paths. Okay, all paths are same. Okay, so you can use perpendicular axis symmetry, and I don't like calling it parallel axis symmetry, perpendicular axis symmetry, because all you have to do is, there's only one thing, which is path symmetry. Okay, so using path symmetry, we say this is perpendicular axis symmetry or parallel axis symmetry, but the main thing that we are talking about here is path symmetry. So when we understand path symmetry, what we can do is two things. We can either identify the equipotential points, or number two, we can distribute current. Okay, we can distribute current very easily. So I'll give you an example of using path symmetry to identify equipotential points. Okay, so the first thing is that we should look at the current distribution. Now what we're going to do is I'm going to connect this to an external battery, let's say V, and let's say this current provided by this battery is I. Okay, now from here it is getting branched into three branches. Okay, it is getting divided into three branches, this branch, and this branch. Okay, now by symmetry we can say that all of these three branches are the same. You replace one resistor by the other, you replace the first resistor by second, you replace second resistor by third, what you're going to find is it's the same. There's going to be no difference in the circuit, which means that the current is not going to have any preferential path. Okay, the current is going to be same through all these three branches. Do you agree with that statement? All these three paths are same, then why should the current be different in these three paths? So the current is going to be the same. So it is going to get distributed equally. So I by 3, I by 3, I by 3. Correct. Now when we reach this point, it is again getting branched into 2 points. Okay. Now you can take this route or you can take this route. Is there any difference between these two routes? Obviously there is no difference between these two routes, which means that the current is going to be divided equally. So this is going to become I by 6 and this also is going to become I by 6. And same here we can say this is going to become I by 6 and this is also going to become I by 6. Is that correct? Is that clear? Okay, I'm sorry, this is not going to become I by 6. So the argument is over here. This becomes I by 6 and this becomes I by 6. Now the same argument we can apply when we are collecting current out of B. Remember we had this discussion. Now all this current is getting accumulated at B again, which means that the paths leading to B, they are also the same. So the final current coming out of B is going to be I. Whatever has gone in, that is going to come out. So which means that all these three paths that are here, okay, these three paths that are over here, they are equivalent paths. Okay, any of the three paths you take which is arriving at B, all these are equivalent paths, which means there is no reason for current to be different in these paths. So this also has to be I by 3, this also has to be I by 3, and this also has to be I by 3. Is that correct? Okay, now using this, what we can do is we can do two things. One, we can apply KVL in one loop because we have only one variable which is I. So we can apply KVL in one loop, or what we can do is we can identify equipotential points. So the current, the potential over here, the potential over here, and the potential over here. So from this point we are undergoing same drops in potential. Okay, the drop in potential is going to be I by 3 into R. So we have same drops in potential, so we can join this point, let's call it 1, we can call it 2 and 3. So with these 1, 2, 3, all these points are equipotential points, so we can join them and then we can see series and parallel combination. That is one way of doing it. Okay, but in this particular question it is not very helpful. What is much more easier is writing one KVL, and I'm going to write that KVL. Okay, so what is this point? This point is A. I'm calling this point B, I'm calling this point C, and I'm calling this point D, or this is B itself. Okay, this point is B itself. So my path, I'm going to take it as A to B to C to B and through the battery back to A. This is the path I'm going to take to write the KVL. Okay, so let's start. So let's start with AB. Now I'm going in the direction of the current, so that is going to be minus I by 3 into R. Now I'm going from B to C. Now when I'm going from B to C, I'm going in the direction of the current, so I have to write minus I by 6 into R. And then I'm going from C to B, so again I'm going in the direction of the current, so this is going to be minus I by 3 into R. And then through this battery I'm going, so this is going to be plus V because I'm going from negative terminal to positive terminal, and then back to A, so this is going to be equal to 0. Is that right? So if I calculate this, what I'm going to get? I'm going to get V is equal to, you take the LCM and you're going to get 5I R upon 6. Is that right? If you take the LCM, this is going to be 5R by 6 into I. But what will be the equivalent resistance? The battery has a voltage of V and the current it has supplied is I. Okay, to the entire circuit, the current it has supplied is I. So what will be the equivalent resistance? The equivalent resistance is going to be V by I, and that comes out to be 5R upon 6, and that is going to be my answer. Right, Tanmay, you can either find equipotential points or you can find one loop to write current like this if you just have one variable. Okay, in this case, you just have one variable I. You can express current in all the branches using I. So the easier method in this case is going to be writing KVL through one loop. Okay, otherwise if you are not able to establish that, then yes, certainly equipotential point is going to be the method that we will have to follow. But in this case, since I can write the current in all the branches in just one variable, it is easy to solve it using by writing KVL in one loop. Is that right? Alright, so the correct option, the correct answer should be 5R by 6, and the correct option, of course, is going to be, the correct option is going to be option C. Okay, so that's it for this session. Okay, I hope you go back and try and practice problems on circuits. Okay, and try to follow the method I have told you. Okay, go with series parallel combination, Wheatstone bridge. Then if you're not able to find that, find symmetry. If you're not able to find symmetry, see combination of cells, see superposition, and finally if there's nothing that you can do, then apply KCL and KVL. Okay, but it is very unlikely that in an exam you will be asked to apply KCL and KVL in a very complicated circuit. Okay, if that is the case, then either leave the question or there's something which you are missing. Okay, so go back, practice symmetry and try to improve on this particular aspect, because if you do that, you're always going to get a lot of advantage in capacitors as well. Okay, so thanks a lot for attending the session. I'm always very happy to see the familiar faces. You guys are super interactive. You guys are super, we have such a good conversation. We have such good chemistry going on, even though we are talking about physics, but we have such good chemistry going on, and that motivates me to come back and do more sessions. All right, so till then, till we meet again in the next session, all right, enjoy yourself, keep practicing and have fun with learning. Thanks for watching.